Hello everyone, this is Rani, and in this video I would like to discuss about regular Faisi method. Okay, so let us see what is this regular Faisi method states and how it will be useful in finding out the solution. Okay, right. As we have discussed, there will be two different kinds of equations like transcendental equations and polynomial equations. So in this topic, we are going to discuss how to find out the solution of the transcendental equation. As a part of this, the second numerical method we are discussing is regular Faisi method. So this is also one of the iterative method, and how this what is the iterative formula in this regular Faisi? Let us see. Right. So here, as usual, what we are supposed to do is we need to find out what is the first. Let us consider y is equals to f of x with the given curve equation. So from this, we are going to have what is f of x. So step one, let us identify what is f of x. Here, no need to calculate any derivatives. So in this second step, estimate the interval where the root lies between. That is a comma b interval. In the third step, we need to calculate x0, x1, x2, x3, all successive values of the root, right? By using some iterative formula. What does that iterative formula mean? That is nothing but xi plus 1 is equals to xi minus f of I plus 1 minus f of xi, okay, into f of a divided by f of xi plus 1 minus f of xi. So like this, by using this iterative formula, this one, we can calculate the approximation root of the given transcendental equation. Here they have chosen like the instance interval is a comma b, f of the approximation for this Newton regular Faisi method is XRFP, which is equals to A. A is nothing but a first value in the interval A comma B. Okay, so A minus f of A into B minus A divided by f of B minus f of A becomes the iterative formula every time. So by using this iterative formula, we are going to calculate the all successive approximation values of the root x. So how many iterations we should calculate means until the value gets repeated here. So in any two successive approximations, if the value of the x gets repeated, that repeated value should be considered as final approximate root of the given transcendental equation. So what is the working rule here? First, we need to consider what is f of x. What is f of x? Next, estimating the interval. After estimating the interval by using this iterative formula, either this notation or this notation, we can calculate all successive approximations of the root. And we need to find out the iterations until the value gets repeated, and whatever the value gets repeated, that repeated value is nothing but our required approximation root of the given transcendental equation. So by following all these steps, let us try to find out the solution of the transcendental equation by considering one of the example. So here, if we consider the example is f of x is equals to x into e power x minus 2. F of x is equals to x into e power x minus 2. Okay. So next, immediately we need to find out the interval x belongs to open interval a comma b. So for that, what we are supposed to do, we need to substitute continuously 0, 1, 2, 3 and all. So f of 1, we are getting positive, that is greater than 0, and f of 0.5 as negative value. Okay, so the root lies between open interval 0, 5, 1. Means the root lies between 0.5 and 1. Means answer will be like 0.6, 0.7, 0.8, otherwise 0.5, 56, 0.71, 0.8, 0.9, 0.99, etc. Okay, whatever the value lies between 0.5 and 1, our answer. So therefore, now let us start with the procedure. So we got two successive values, means in between the root lies between, that is 0.5 and 1. So these two values will be considered as x0 and x1, first two approximations of the root, x0 and x1. So next from iterations, first iteration, like here, first iteration, we should calculate x2. Okay, so we will calculate x2 in the first iteration. According to the formula, this x2 will be represented as x0 minus x1 divided by f of x0, f of x1 minus f of x0 into f of x0. Okay, so we have all the values here. We have considered x0 and x1. By substituting these two values in f of x, we are going to have f of x0 and f of x1. So let us put all the values here and calculate what is this x2. x2 is equals to 0.8098. Okay. And immediately after getting this x2, we need to find out f of x2 also for further approximations. Right. So in the first iteration, we calculated x2. And this x2 and x1 are not getting repeated. We need to observe, like you see, the successive approximations of x are getting repeated or not. Here, the successive approximations of x are x0, x1, x2. So if you observe these three values, x1 x1 are not getting repeated. And similarly, x1 and x2 are also not getting repeated. So what does it mean? If they're not getting repeated, we are supposed to move on for the next iteration, which we are calling here as second step. Okay, so again, we need to estimate the root lies between where and where. Now here the root lies between x1 and x2. How? x2 is what here? It is a positive value. And x1 is f of 1. Okay, so the root lies between x1 and x2. What is x3 here now? x3 is equals to x2 minus x1 minus x2 divided by f of x1 minus f of x2 into f of x2. So since we have all the values with us, like x2 is there with us like the 0.8098 and x1 is also there. What it is, x1 is 1. x1 is 1 and f of x1 calculated, f of x2 just now calculated. Let us put all the values here and calculate what is x3. So what is x3? 0.8479. So now after getting this x3, we need to check whether this x2 and x3 are getting repeated or not. What it is? 0.8098. Here it is 0.8479. So after decimal, only one digit is getting repeated, like 8. 0.8, 0.8. After 8, no value, no digit is getting repeated. So what does it mean? We need to go with the next approximation, that is third step. So in this, we should calculate x4. So for that, the required information is f of x2. So before moving on for this third iteration, let us calculate f of x2 also here. Okay, which is negative value here. Right, f of x2 is negative. We need to search positive value. Right, we need to search positive value. The root lies between positive and negative. So therefore, x3 and x1 are the two values where the root lies between now. So which implies x4 is equals to x3 minus x1 minus x3 divided by f of x1 minus f of x3 into f of x3. So therefore, by substituting all the values, we got x4 as 0.8519. So again, after getting what we're supposed to do, we need to check the repetition digits after the decimal. 0.85 here, 0.84 here. So nearby, but they are not getting repeated. At least 2 or 3 digits should get repeated after the decimal. Only one digit 8 is getting repeated. Okay, so now next fourth iteration. Before going for fourth iteration, we need to find out f of x2 after getting this x4. This is again negative. Okay. So this is, since it is negative, we need to search positive. Again, the positive is f of x1 only. So the root lies between x4 and x1. So therefore, the next iteration x5. x5 is defined as, according to iteration formula, x4 minus x1 minus x4 divided by f of x1 minus f of x4 into f of x4. So What happened here? After substituting all those values, we got a iteration value, that is 0.8525. So let us again check the repetition here. So to check the repetition, 0.85 here we can see in this x5, whereas in x4 0.85 means after the decimal 2 digits are getting repeated here, 0.85. So after 85, whatever it is, it's okay, can be considered. Minimum 2 or 3 digits should be repeated. So since 2 digits are being repeated and the repeated value is 0.85 and last approximation value is 25. So that should be considered as a final one. So therefore, the answer for this means the required root of this transcendental equation is 0.8525. Okay, so like this regular Faisi method will be utilized to find out the root of the given transcendental equation. Similarly, one more example also there. The same procedure. First, we need to estimate what is the interval where we are going to have the root in between. So 2 and 3 we got. Okay. So those two values should be considered as x0 and x1. And immediately next iteration x2 should be calculated with a required regular Faisi iteration method. We call it as 2.64286. Right? And if you compare this x2 with x1, no value is getting repeated. So we need, what does it mean is we need to move on for the next iteration. But to move on in the next iteration, we need to estimate the interval again in where the root lies between. So here, this f of x2 is how much? F of x2 is negative here. We need to search positive value. Which one is positive means f of 3 is positive, this one. So the root lies between x2 and x1, 3. Okay, so by using these two values, by applying this iteration formula, we need to estimate what is this x3. That is 2.73564. Immediately, we need to consider f of 2.73564 also for further iteration. So for further iteration, again we need to estimate this interval. So for that, f of x3 is negative, means we need to search with positive. Again, it is 3 only. Here, positive value, right? Functional value. So therefore, the root lies between x3 and x1. So that we got x4 as 2.7461. This is x4. So let us calculate f of x4 also. And the f of x4 is negative, so we need to take positive. Again, the positive is the same, x1 equals to 3. So the next iteration value x4, next iteration value lies between x4 and x1. So x5 is equals to, we got 2.7472. And if you compare this x5 and x4, 2.74 means after decimal 2 digits are being repeated here, 2.74, 2.74. So minimum whenever 2 digits are getting repeated, we can consider them as approximation value. Otherwise, we can still move on for the further iterations. And if we move on for the further iterations, more number of digits after the decimal will get repeated and the answer will be almost equal to the accurate actual answer. So here we can take the final answer as 2.7472. Here we have taken one more iteration. There we got 7473. So that will be the final answer. So like this, by following these kind of procedures, we are supposed to find out the approximation root of the given transcendental equation using regular Faisi method. Okay.